Now that we've talked about translations, we're going to talk about reflections. And reflections is a transformation that uses a line like a mirror to reflect an image. And a reflection is also an isometry. So remember, an isometry means that it keeps the same size and the same shape, and it is a congruent transformation. The line of reflection is the mirror line that you reflect everything over. So in this first picture, well, and really in both of them, the pre-image, remember that's the original figure, is going to be our point P. And then the image, the new figure, is going to be the point P prime, because that's where it reflects it over. And if you notice, they are the same length, same distance away from that line of reflection. So we're going to use that later when we need to graph things. And if you notice about the second one, if our point P starts on the line of reflection, and after it's reflected, then it will still stay on that same line. Since it starts 0 units away from the line because it's right on the line, it stays 0 units away after reflected. All right, starting out on each of these, we need to have the original coordinates, so our pre-image coordinates, and that's what they are in -3, 0. 4, -2 is my B, and 3, 3 is my C value. And if you see, I have my line of reflection is the x-axis. So what you want to do is we want to look at it and just graph it on the opposite side of that line. So our A starts on the line, so remember that's just going to stay on the line. Next, my C, if you count up, it is 3 spaces up, so I need to go 3 spaces below. So then that would be at 3, -3. For my B, it is 2 spaces below, so I need to go 2 spaces up, and then there would be my B. So it would be at 4 and now +2. So what do you notice with each of our coordinates? So if you look at each of your x's, all the x's stay the same, but our y values, we can't tell anything with a 0, but with our y's in each of these, if you notice, they're opposite signs. So that means our x value stays the same, but our y's are changing to the opposite sign. Next, we're going to do the same thing now for the y-axis. So now that we have all 3 of our coordinates for the original figure, so our pre-image, when we graph it across, we reflect it across the y-axis, we want to count the number of spaces. So notice our x is 2 spaces away, so we want to go 2 spaces away on the other side, so our x prime will be right there, and that would be at -2, 4. Next for the y, we can count over, and it is 6 spaces away, so we want to go 6 spaces away on the opposite side. 1, 2, 3, 4, 5, 6 right there. So that'd be my y prime, so that's at -6, 2. And then lastly for the z, it is again 2 spaces away, so I need to move 2 spaces away. So my z prime will be right there, and that would be at -2 and -5. So when we look at the actual coordinates again, if you notice each of our x's, notice all of them are different signs. So it made all of our x's the opposite sign, but it kept the same number. And then our y values, it looks like all of those stayed exactly the same. So instead of the y's being opposite signs, now it's the x's that are opposite signs. For this one, we're going to reflect across the line y equals x. And if you notice, the slope is going to be 1, and the y-intercept is at 0. So you just have to remember that that is an actual line, so think of your slope-intercept form when you're graphing it. And you can see all my coordinates are already written out, and that's where our s and t are written. So now if we want to graph the reflected coordinates, what you want to look at is you want to go exactly diagonal. So if you notice, from s exactly diagonal, I got 1 box and then a half a box. So I want to go half a box and then 1 box. So that's where my s prime is going to end up, and that is at, let's see, 2, -1. Then for one that's a little bit further away, my t, you can see that I've got 1 box, 2 boxes, and a half a box. So the other half, 1 and 2 boxes. So there's where my t prime is going to end up. And that is at, let's see, -1, -6. For the r, I'm going to choose a different color because it's going to overlap a little bit. So there's 1 box, 2 boxes, 3, 4, 5 exactly. So then 1, 2, 3, 4, 5. So that's where my r prime is going to end up. And that is at 6, -4. So we want to look at what we can notice. So looking at this first set, if you notice, these are the same numbers. So it looked like it took the y and it put it now in place of the x. So that would be my y is now my x value. and it took my x value and it flip-flopped it. So basically just switched both of the x's and the y's. All right, you want to make this huge on your paper because you need to know how to reflect it. So if you want to memorize the rules, this is what the rules are right here. There's 4 different lines. We did not do y equals negative x, but that would be easy enough. The slope would just be -1, but the y-intercept would be 0. Or you can graph it like we did on the graph when I just showed you the last 3. So some of you might memorize them. Some of you might just use the graph and know how to reflect it, and it really doesn't bother me which one you do. So for this very last question, we're going to combine 2 of the things we already know. We're going to reflect and we are going to translate. So first off, we need to graph our point -3, -7. And that's where I've got right now. So -3, -7. I need to move it to the left 1 and up 4. So if I go to left 1 and 1, 2, 3, 4, I'm going to end up right here. So left 1 and up 4. Then I want to reflect it across the line y equals x. So remember, line y equals x. See if I can make this pretty straight. There we go. Okay, so there's my line. And if you notice, this is only a little half a box away, so it needs to be a half a box away on the other side. So that's where I need to end up for my h prime, and that is at -3 and -4. So let's check our coordinates. Our answer should be letter A. And if you look at what I did with my coordinates, I went back and I filled in what the coordinates were. So for the first, here's the original coordinate. If I went to the left 1 and up 4, this is where it ended up. And then if I reflect it across the line y equals x, this is the rule. So right here it says b and a, but it's the same thing as my x and y. So I'm switching the x and y places. So I take my -3 and now it's my x. I take my x value and now that is my y. And if you notice, that's where we ended up on our graph. So you can use just the graph itself, or you can use the coordinates or a combination of both to find your answers.